Alright, so on this quiz, we did inverses, we found inverses of functions, and we did those exponential formulas for the word problems, right? Liam, put that down, please. John, you too. Alright, so these logarithms that we're going to do are the inverse of these exponential ones that we did on yesterday's quiz. Okay, so here's a little example. It says, how many times would you have to double $1 before you had $8? You could use an exponential equation to model this situation. 1 times 2 to the x power equals 8. Again, it's an exponential equation because the variable is where our exponent goes. You may be able to solve this equation by using mental math if you know 2 to the third equals 8. So you would have to double the dollar 3 times to have $8. All right? Got $1, double it, $2, double it, $4, double it a third time, $8, right? But what if you wanted $512? How many times would you have to double the dollar? All right, you could solve this problem if you could solve 2 to the x equals 512. So we're looking for what x equals there, so we know, how many times we'd have to do that. It says by using an inverse operation that undoes raising a base to an exponent equation to model this situation. This operation of undoing raising to a power is called a logarithm, or finding the logarithm. So what we're looking for, the logarithm is the exponent we're looking for. Okay? So when I say the logarithm of something is 3, that means its exponent is 3. The logarithm of something is 2, that means its exponent is 2 with that whatever base we're talking about. Okay? So this is what you really need to learn today. That this exponential equation, this base raised to this power equals this number. When you write it as a log, it's log base b. Base b, the b's the base over here, b's the base there. That's a subscript we call, of the number equals the exponent. That's what a log equals, the exponent. So that's why the red x is over there. So you need to be able to look at an exponential problem and rewrite it as a logarithmic problem, as well as looking at a logarithmic problem and rewriting it as an exponential problem. You guys did this last year. You were really good at it, all right? And this year, you'll still be good at it, again, all right? What you got to make sure of is that your base is positive. That's what this is saying. And your base will never be 1, all right? We'll never have log base 1, or we'll never have 1 to the x power, because we always know 1 to any power is going to be what? 1. We already know that, right? So if we look at go back to that very first example, we're saying 2 is the base, 3 is the exponent, equals the number, which we know is 8. So there's our exponential problem. All right. You need to be able to rewrite it as log base 2 of the number, which was 8, equals the exponent, which was 3. Okay? So that's what you really need to learn today. And once you learn that, you'll understand how to maybe look at this problem. And you'll say, find log base 2 of 8. And you'll be able to think, well, that means 2 to what power is 8? And then you'll say, oh, yeah, that's 3. That's easy. Okay? So, any questions? Is it coming back to you maybe from last year? Hopefully. That's not moving over there, is it? Sorry about that. All right. So, Chase, 3 to the 5th is 243. Put that in log form for me. Oh, come on. You were just daydreaming again, weren't you? Let's go. It's written like this for you. I want you to write it like this for me.
I think
The base is after the log. Whatever this equals comes after for the number, and then the exponent is what it equals. So, 3 to the 5th is 243. Log
log 3
of,
3.
no,
Log 243.
yeah, log base 3 of 243 equals
5.
5, yeah,
I thought you were, yeah, I thought you were asking for that lower number.
okay? Just want you to rewrite it as a log problem. Liam, this is not quite right now. Let me fix it. Oops. There we go. So it's 25 to the 1/2 power equals 5.
The log base 25 to the 5th
This of 5
of 5.
equals 1/2. Good. Log base 25 of 5 equals 1/2. Cody,
Log base 10. 10,000 equals 4.
right. Log base 10 of 10,000 equals 4. So
Log base 6 of -1
no,
of 1/6.
right. Log base 6 of 1/6 equals -1. Nikki,
Log base A of C equals B.
good. Log base A of C equals B. You doing all right?
Yeah.
All right, Tasha.
Log base 9 of 81 equals 3.
Good. Log base 9 of 81 equals 2. Jamie.
Log base 3 of 27 equals 3.
Good. Carter. Don't worry about this parentheses stuff. Just, it's x to the 0 is 1 is the problem.
Log base x 0 equals 1.
Flip. Log base x of,
0.
yeah. Log base x of 1 equals 0. Okay? So no matter what the base is, if the number 1 comes after it, the answer is always 0. Ashton, making sense?
Yeah.
Good. Do this one, please. Go the other way.
Is 9 to the first power equals 9.
Good. The base is 9, the exponent's 1 equals the number 9. Christopher.
2 to the 9th equals 5.
Good. Kyle.
8 to the 1/3 equals 2.
Good. Sydney. Now remember, we say this is log base 4 of 1/16 is -2. So the base is 4. So we went, remember, here's the base is 8. Oh, there you go. You can't see that. Base was 2, exponent's 9 equals a number. So base is 4, exponent equals 1/16. Good. Carter.
B to the power of 0 equals 1.
Good. We knew that. Anything to the 0 power is 1, right? Okay, Chase. Good. Zach.
12 to the power of 2 equals 144.
Good. Kennedy. Right. 1/2 to the -3rd power is 8. We're getting it, right? Starting to come back?
That's pretty hard, actually.
Steamboat. Yeah, it's because your computer's. What?
I did it.
What? You did it.
I'm actually with that one.
Come on, let's stay focused. This won't take us long. We got a few more to go through. Oh, come on.
My favorite.
I'm sure it happened.
Really? How many followers you get?
1 minute.
Bunny.
Wait. Hold on.
My mom taking things.
Oh, yeah.
My mom taking things.
Why didn't you hit it? You show your, you guys grab my hand. Oh,
All right,
okay. It was.
we had a little technical difficulty there. All right, John, let's go. Couple properties, special properties of logarithms. If the base and the number are the same, so like log base 7 of 7, if they're the same, what's the answer always going to be? 1. Basically, what do they do to each other? Right, they basically cancel each other out. So when the base and that number after the log are the same, answer is 1. Okay? Whenever you have any base, let's say base 3, and the number is 1 after the log, the answer is always 0. Because what you're thinking is 3 to what power is 1? All right? Any number to the 0 power is 1, so that's why the answer is 0. So whenever you see that 1 after a log, it's going to be 0 answer. All right? A logarithm with a base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. You will see this in books where there's no subscript. If you don't see that number, that little subscript, it means it's 10. You're supposed to know that it's 10. Okay, Abdul? Okay?
Wait, yeah.
All right. Any other time?
It means the little number?
Yeah, it means the little number is 10 if there's no number there. It means the base of the log is 10. All right, and that's the one that's in your calculator. Okay, all your calculators, your scientific ones and your graphing ones, about this same area on the left side has the log button. Okay, those little pink ones and navy blue ones that you guys got too. It's on the left side, somewhere down the side there. All right, and should be right under it, ln, which is called the natural log. That's when the base is what? No, E. The ln one is when the base is E. The log without a number, subscript, is the common one. The one you calculate. You will see this once in a while. You will see log and then an E. All right, that's the ln one. Okay, and that's one you can do on your calculator as well, if you have one like that. So if you have a log with no base, you can just punch in the calculator and give you the answer. If you have an ln, you can punch it in and give you the answer. All right, we're not going to be punching it in the calculator today. We're going to be doing it with this calculator mentally. All right, but here's a couple more. They call these the inverse properties of logarithms and exponents. You'll see stuff like this also. Maybe log base 5 of 5 to the third. Well, if there was no exponent here, the answer is what? What did we say? When there was no number. I had that log base 7 of 7 I showed you. That was a 1. But if there's an exponent up here, then it's whatever that exponent is. Again, these will cancel each other out. Okay, so sometimes you'll see that extra exponent. So we got log base 5 of 5 to a power, so we got 5 as a base again. Sometimes you see this weird looking one. You'll see like 5 to the log base 5. Maybe x plus 3, let's say. What's that 5 and the log base 5 do to each other? They cancel each other out. Same thing. Okay? So those would just cancel, and it's just whatever comes after the log then that's in the exponent there. So that's kind of weird looking, but that'll show up once in a while. But whenever that shows up, they're always the same base. At least for now, for today. All right, so those are some special ones that, just looking at them, you should be able to get them. All right, so what's A here, Jamie?
Three to the 11 equals 3.
Well, yeah, 3 to what power equals 3 to the 11?
Oh, wait, it cancels out with the 11.
Correct.
Okay.
Yeah, those are the same, right? So it's just the 11. Okay? What about this C one? Liam?
Five.
Yeah. Again, this is a subscript, so it's kind of hard to see, I know. But those are the same, so whatever comes after is the answer. Okay? Mr. Walls, Michael. How about that middle one?
Four?
It is 4. Ashton, how'd you know?
I literally just said four.
But here's how I do it mentally. I always like to write this, okay? So what is that exponentially? 3 to the, well, for now though, if that's equals x, 3 to the x, right? Isn't that what we just learned? Went over, reviewed, right? All right, so, you can think about 81 as 3 to the 4th, right? So if I have this side equals this side, if these are the same, I just say these are equal then, right? Whatever those are, which is what Ashton said, 4. Good guess. Or you were looking ahead.
No, I really just said four.
So again, just do this. So what am I thinking? What's the exponential form of this? Yeah, so 8 to what power is 1? Yeah. And I told you that before, right? If the number is 1, it's after the log, the answer is always 0, right? But this is how you should think about it. If you see a log problem, think about it this way, and usually you can figure it out. So again, if you think of it like this, 5 to what power equals 5? First power, right? And we just said that was one of our properties, right? Those cancel out, the answer is 1. But again, that's how you should think about it. And if you start thinking about it that way, it makes it pretty easy. So what's this? What's the exponential form? 4 to the x is 16. So it's 2, right? 4 squared is 16, right? Making sense? Pretty easy, right? How about this one? All right, say that again, Kyle. Oh, Chris? Sorry. Right, the base is 10. Why is it 10?
There's no little big.
There's no little number, right? All right, so when we're doing these mentally without a calculator, you want to try to have everything with the same base, right? Like this, I could have written as 4 squared, right? With a 4 for the both bases. This one we wrote with 5 as the both bases. This one we wrote, I guess, 8, because when it's 1, we just know it should be there. So I want to try to write the 100 with that same base, right? What's 100 if I use base 10? 10 to what power? 2, right? So we're still not quite there because this is 10 to the x and this is 1/10, right? Yeah. Remember back a while, if we want to move an exponent out of the bottom to the top, we make it negative, right? So what's x got to be now? -2, right? That's our answer. Okay? Now, since this was base 10, common log, I could have just done this. Log. Whenever you hit log, it brings that left parenthesis. So make sure you close it off. And there's that -2. So that's one it'll actually do for you when it's the common log, the base 10 one. All right, these making sense? All right, let's see who can figure this one out. So how should I think about this? Well, put equals x, right? So can I write it exponentially? 3 to the x equals what? Well, the 5th root of 9, right? That's what that means. That's called an index. You know, square root, we don't put a number, but we know it's square root, right? The index is 2. Cube root, what's the number? The 3, right? 4th root would be a 4 there. This is 5th root. There's a 5 there. Okay. So how can I write 9 with that base? Three to what power? 2nd, right? Isn't that what 9 is? Now, here's something you should know, but you might not. If I had the square root of 9, that's 9 to the 1/2 power. If I had the cube root of 9, that's 9 to the 1/3 power. So what's the 5th root of 9? 9 to the 1/5, right? So I could say 3 to the x equals 3 squared to the 1/5 instead of the 5th root. Those are the same problem. What's the rule for those exponents inside and out? What am I supposed to do with those? Multiply, yeah. Somebody was going to say that, right? So what's 2 times the 5th? 2/5, right? So now I can tell what my answer is. What is it? 2/5, yeah. That's the answer to that problem. So we did that without a calculator. Tomorrow I'll show you how to use a calculator, do all of it. But doing it mentally, they always make us do this way in the books too. In the beginning, try to do it using mental math because you understand what's happening, what you're looking for. Remember, log is what you're looking for. You're looking for the exponent, right? So you rewrite it or rethink it as an exponential problem. Making sense? Hopefully, this is coming back from last year too. This is really pretty easy once you get the hang of it. All right? So here's your homework assignment. 4 to 40 by 4s. So it's really not that much. I think it's 11 problems. Won't take you long. Good job today. Thanks for participating. I'm going to take some of your laptops, though.
I'm good.